Hello everyone, welcome to week 7. I hope you have enjoyed last week's session because last week you only had to kind of review and kind of go back to your loop, while loop, for loop, and kind of understanding those, and also you had to kind of read a little bit more about how to document things, and basically we talked about functions, and we also talked about the iteration. So all of those was kind of a review for you that you kind of had to do, and then we talked about the class variables and all that. So in this chapter, actually we are going to skip one chapter, so we are not going to cover chapter 7 for now, but we are going to start on chapter 8, which is about classes. I just want to tell you a little bit about next week, what's going to happen. Next week, you're going to have your midterm. So I'm not going to cover any more material. You can focus on the midterm. And also, I kind of give you some more material to read. But you're not going to be responsible for another assignment next week. So only this week you have an assignment. Next week you only have to do the midterm. And the midterm will cover everything that we talked about until end of this week. So it's going to be the 7 weeks. So I know we skipped 2 chapters. So I'm not going to ask you about those 2 chapters that we skipped. So definitely we are not going to talk about chapter 7, which we just skipped. And so you just don't have to worry about those chapters. And we will just going to focus on the chapters that I have covered in the PowerPoint, and you have actually done the assignment. Just to let you know a little bit about midterm, the midterm will be multiple choice and kind of essay question. In a midterm, I'm not going to ask you to do coding, but the final will be different. So in your final, you will have to code, but right now in the midterm, it's going to be multiple choice and some essay questions, so you're just understanding the concept. You all took a quiz, which kind of the quiz was like that. It was kind of filling the blanks or multiple choice. So it's going to be a little bit harder than that. The level is going to be higher because your quiz was kind of very straightforward. So, but it's not going to be that difficult. I'm sure you're all going to do well. So let's talk about this designing classes, which is the topic of this week's lecture. So basically, maybe by now you have used the classes and you have used the Java library and used other people's classes, but sometimes maybe you don't want to use that. You want to make your own class, which is not impossible, and it is kind of easy to do that, but you need to follow certain rules, and in this week we are going to cover that. So to be a good designer and to be able to design something, even if it's a system that you're designing, you basically have to understand the user specification. So that user requirements is very important for you to understand, and also understanding how you can actually convert that requirements into your design. So that's kind of an art that, maybe not everybody have that, but I'm sure if you practice it, you're going to get it. So let's talk about today lecture, which how to write classes in a way that they are easily understandable, maintainable, and reusable. Because as you can see, you are using somebody else's class in your program. So you want to be able to design something that is kind of understandable by other people so that they can use it in their program as well. And so you want to design a class that is basically reusable. And also, as we mentioned about user documentation, that is also important. So you want to keep that in mind as well. So some of the main concepts that we are going to cover, we are going to talk about, these are just concepts that is important for the design. We are going to talk about responsibility-driven design, coupling, cohesion, and refactoring. So again, why we want to actually design? basically software is changing, so basically when you create a software, maybe it's not going to stay the same for a long time. As you can see, the world is changing all the time, so our softwares need to actually kind of be up to speed with that. So the user's requirements are always changing, so our software is going to change. So once you write something, that doesn't mean that it's going to be changed. So you want to be able to write something that is reusable, that something can maintain it when they're responsible to maintaining that code, know how to maintain that and make changes to it. So basically software is extended, corrected, maintained. It can be also ported and adopted somewhere else as well. So the work is done by different people over time, or even often decades. So normally software companies, maybe if you work for a software company, you might leave, so somebody else is going to take care of that coding. I can give you an example. I used to work as a system analyst before in a company, and I was responsible for some old software that was written for the payroll system. It was in COBOL program, and I couldn't understand COBOL because when I graduated, I just learned C++, Java, and all that. So COBOL for me was like old language. But in order to be able to maintain that, I had to kind of understand that. And of course, I had other people who knew COBOL, so I had to learn a little bit and understand it in order to maintain that software. So then after, of course, they moved to the enterprise resource planning software, which is like SAP. So they have changed it to kind of a newer things that was in the industry. But again, those programs, I was responsible for maintaining those old COBOL programs. So I had to kind of understand them. And again, at that time, there were not many people would emphasize on documentation, on kind of reusability and all that. But Java and C++, object-oriented programming, always give that opportunity. So, and as you can see in this course, that you learn about documentation, you learn about reusability, you are using other people's classes. So it is kind of, that's how the programming language is going on nowadays. But in the old days, it was not like that. So if you cannot change your software is gonna die. So if, for example, that example that I gave you, if that company wanted to stay with their old COBOL programs, and use the for the payroll system, it would have had a lot of problems, and it couldn't be competitive anymore with the market. So you need to actually make changes to your software systems to be adaptable to the new changes that are happening in the industry. So that's very important. So there are only two options for software. Either it's continuously maintained or it dies. So if we cannot continue to maintain it, if it becomes more hard for people to maintain that software, it's not going to work anymore. And as I said, it's not going to be compatible. Software that cannot be maintained will be thrown away. Again, the same thing that happened because it was so hard to maintain that COBOL program anymore, so they threw it away and they replaced it with another software. So that's why nowadays you want to design softwares that are maintainable so it can last for a long time. And again, in the world of IT, change happens all the time. So you have to be adaptable with change. You always have to be updated with the program that you are using, with the methods that you're using, and all that. So in this, week, and for this chapter, we are actually going to look at a project. As you know, we are always looking at the project in our chapters. So we will use an example called World of Zool. So basically, this is in its original state. The game is not actually very ambitious for one thing. It is incomplete, but by the end of this chapter, you will be able to position to exercise your imagination and design and implement your own game and make it really fun and interesting. So we are going to actually look at World of Zool, which is kind of an original adventure game that was developed in the early 1970s by Will Crowder and expanded by Donald Woods. So you can read more about this in the introductory part of this chapter and kind of understand about this project. So I just want to mention to you, you will find two versions of this project. One of them will be Zolbad and Zolbetter. So both of them implement exactly the same functionality, but some of the class structure will be different. So the Zolbad would represent bad design in one project, and Zolbetter is actually showing you a better design in another project. So, but the functionality of it would be the same. So we're just going to understand the difference between the bad design and a good design. So as we said, we are going to go to this word of Zol. So just basically quickly, I'm going to explain to you what this game is about, and maybe you can read more further. So basically, this was kind of a cave system, which the user would be able to locate hidden treasure and use some words to open, other mysteries or treasure. And so basically, the effort was to get the maximum number of points. And at the end, maybe the user would get lost or would find the treasure. So basically, this is kind of a explanation of the game. But as I mentioned, we are going to have Zulbad and Zulbetter. So this is just exploring Zulbad. We, of course, in our program, we will have classes. So in this game, basically, we have 1, 2, 3, 4, 5 classes. So, and these are the class names: the game, parcel, command, room, and command words. So these are basically the parsers that we have. Classes that we have. So the game is basically the starting point, and it's a place that controls the loop. Room is actually the location. The parser is basically how computer reads the user input. Basically, command is the user command, like for example, whatever the person is actually putting in the keyboard, like go, stop. And the parser is basically reads that user input. And command words recognized user command. It's going to kind of recognize it, that this is the command, and it's going to do that action. So again, if you're going to look at, you can actually open this for yourself from the project folder and look at the classes. And so we're going to talk about the code and design quality. If you are to be critical of the quality of this code, we need to be able to have some sort of a criteria. So if you are going to say this game is bad, so you need to have some sort of a criteria that you say, okay, based on these criteria, this game is not designed well. So some of the criteria that we're going to look at, and these are the concepts that when we are designing the classes, are basically coupling and cohesion. We are going to use these for assessing the quality of the program that we are, the quality of the class that we are designing. So before we talk more about coupling and cohesion, let's just go look at the project itself. And if you remember, you have downloaded the projects, and it should be under chapter 8. So we have the Zulbad. You can click on it and then click on package, and it will open the Zulbad. So this is what you saw in the PowerPoint, the 5 classes that we talked about, each of them. And then of course you can click on compile, and it's compiling. So now the program is compiled. There was nothing wrong with the program. So you see compiling is done. So I'm going to try to run this program. So I'm going to create a new game, and because I'm the first player that I want to play, so I'm just going to click there, and then I'm going to right click on this and say play. So as you can see, we have it's the welcome message is coming, and also type help if you need help. And basically you are the location is basically you are located outside of the main entrance of the university. So exit, east, south, west, these are the exits. So I want to actually play this game, so I'm gonna put go. And it's going to ask you, go where? So you can put east, west, so I'm gonna put east. It says, I don't know what you mean. That means if you look at the source code, the only word that it is there, it's going to be go somewhere. So let's put go east. You are in a lecture theater. That's what it is. So let's put west. I don't know what you mean, because we have to put the word go west. Go west. You are outside the main entrance of the university. So I want to say go south. You are in a computing lab. Go east again. You are in the computing admin office. I'm going to put go east again. There's no door. That means you are locked. So you cannot go east anymore. So go south. South is locked too, so you can go out of there. Go west. You are in the computing lab. And then we put again, go east. You're in the computing admin office. And then go south. There's no door, you're locked. So basically this is how the game is. It's a very simple game that we have in here. And we can just look at the source code for these and see how it is actually got created. So basically this is about the game. So let's look at the source code. So I'm going to click on the room, double click on it, and you will see the source code for the room. So basically you have these room, north exit, south exit, east exit, west exit. Remember, we are not typing west exit, east exit, but as you can see in here in this program, that they have the class, if you look at the other one, it's basically east, west, and south. That's what we are typing about. So here is basically the description of it that we put in. In here, it defined the exit of this room. Every direction either leads to another room or no exit there. So that's why you have all these words that is equal. So that's what we said. We don't put north exit. We just put the word north. And that's why it works. East, west, and all that. So you have that. And again, it will basically return the description of that room. So that's basically your room class. So we are going to actually look at another one, command class. So in the command class, remember we're putting two commands. So that's why in here you have a string command word, second word. So you're not using east. So remember when we would put east, it wasn't working. So we had to put go east, go west. So that's the string first word and then the second word that you have here. So you have the command word for the first word and the second word, and it will return the command word. So it was not working when you had only one part of it. So if it was null, if the command word was null, it was not working. So you need to have the second word as well. So let's look at the other classes. Command. Basically, the command is, if you look at this command source code, of course we have the header here, it would tell us what this class is all about. So we have the string command word and then the second word again. And as we said, we have to put both of the word, like go west, go east. So in here you create a command object. First and second word must be supplied, but either one can be null. So you cannot have you cannot only have the first word null or the second word null. First word, the first word of the command, null if the command was not recognized. So that's what we are doing in this class here. This class is very short, and this is what we do here. The next one that we are going to look at is basically the parser. So the parser, which basically reads the command. So the parser gets the command, and then it uses the scanner to read it into the system. So that's what this does. That's what you have the scanner here that it would basically reads the command. And then in this example, you have, of course, your string word 1 and word 2. So go west, go east, and all that. If they both null, this is what it's going to print, and it's going to actually go and read the next line. So for example, if we put go west, then another one, so that's where you have it to go read the next one, is going to be go east. So it's going to read the next one that we have in there. So basically that's what this class does. So the next class that we are going to look at, which is more complex, is going to be the game command, which is combination of all these classes. That's why you can see the source code is a little bit longer. And again, we have the header there. So basically the header is kind of describing what this class is doing. So basically users can walk around some of the scenery. It should really be extended to making it more interesting. But right now, as you can see, it's like go west, go east. So it's going to different location. And, you know, if it cannot go farther, it's going to show you that there's no door and basically you are locked. So to play this game, we create an instant of the class. That's what we did last time. Remember, I created instant here. I created this. So that's what we are doing in here. And the main class create and initialize all the others. It can create all the rooms, create the parser, starter, and all that. So basically you are initializing in this class as well. So in this, if you go here, you can see that you are basically initializing this in here. You are creating the rooms, and then the parser is going to read that, creating all the rooms and link their exit together. So in this, that's where your starting point was outside the main entrance of the university. And then, of course, you have the other ones which you are creating the other rooms in the lecture theater, in the campus pub, in the computer lab, in the computing admin office, and all that. So this is where you are creating all of your rooms, and then you are initializing your room exits. So as you can see in here. And then the next one, of course, you are playing the game. Remember when we played, we got some welcome message over there. And then basically you enter the main command loop here, and you can actually read, the program is actually going to read the command and execute them until the game is over. And that's what you do. So if you finish the process the command, it will say thank you for playing and goodbye. So in here you have some other words that is basically kind of helping you to go through the game. So for example, quit is basically when the game finishes. Help, it will actually print the help. Go, you can actually, it says go where. So you will put a command. So let's see how it was actually working. So if I go back and kind of to my game and say play. Oh, I think I have this. I'm running my game. So hold on one second. Okay, here I found it. So we can actually put help in here, and it says your command words are go, quit, help. So that's basically, you can say these are the words you can use. So go where. Imagine if I put west, it's not going to work. We have to put go west, the two words that we have. And then if I put quit, is that I don't know what you mean. Oh, there you go. So I didn't type it correctly. So quit, thank you for playing, and goodbye. So that's basically when we are exiting our loop and we are finishing our program. So if we look at this code, we see that there are some redundancy of code in the welcome statement. So if we go here, you see all of these And also, if we go look at this, you see that again, same thing. So we can actually come up with a function that says print location info method, or we could call it a method, of course, in Java. So the print location info method will eliminate having all these duplicates writing. So if there is a module, under your module, there is a basically the example that in the recording that you can listen to it, and it will actually show you this exactly. So you are going to replace the code with this print location info method. So you can actually move all of this stuff that are under the welcome message. Let me just go up there. And you can also put it in one code. So every time, under this, you can just say print location info. So it will actually read that method. So you are not going to duplicate the effort. So you can actually, under the module, look at that, look at one of those recordings, and you will see exactly how it's happening. So let's just go and follow our presentation again. So we're going to kind of understand more concepts, and please let me know if you have any questions regarding your assignment this week. I just want to remind you one more time that you can always use the tutor. Just plan in advance so that before you submit your assignment, you can actually get help from her. She's here, she's willing to help you, and she submits her hours to me. So last time I only saw maybe one person getting help from her for 1.5 hours. So I would like you guys to contact and get help before submitting your assignment. Some of you haven't submitted the assignment, and it is very important in order to get a good grade to submit your assignment, because as you can see, most of your grade is based on your assignment. Of course, you have a quiz, you have midterm and final, but most of the grade is on the assignments. So you want to make sure that you are following this and understanding the assignments. So again, some of the things that we talked about is coupling, cohesion, refactoring. Basically, refactoring is eliminating duplicate code, and these are important for important concept for the quality of code. So let's see what is coupling. Basically, coupling, it refers to a link between separate units of the program. So we basically talked about when we are designing our program, we are trying to set some cooperating classes that they can communicate well together via this interface. If two classes depend closely to each other on many details, we say that they are tightly coupled. Our goal is to have low degree of coupling, or basically loose coupling. The degree of coupling, basically, it determines how hard it is to make changes to our program. So if our class structure is in a way that we have tight coupling, a change in one class can actually affect the other classes. So if we want to make a small changes, we have to make that changes in many different classes, which is basically that we want to avoid that. So basically, a class diagram provides limited hints at the degree of coupling. So before we program, that's why it's important to draw our class diagram, so we understand how dependent are these classes to each other, and then we can actually design it in a way that they are designed in a way that it's kind of loose coupling. So in a loose coupling program, we can often change one class without making changes to the other class, and that's the goal that we want to have. And again, our goal is to make our application work. But if we change one class, it's not going to affect all these other classes. So we don't have to make too much changes, and then it's going to be time consuming. It could create duplication. It could create like errors and all that, and you don't want to do that. Another term that we are going to talk about is called cohesion. Basically, cohesion refers to the number and diversity of tasks that a single unit is basically responsible for. So if each unit is responsible for one logical task, we say it has high cohesion. And we actually aim for high cohesion in here. So again, we are aiming for loose coupling or low coupling, but we are aiming for high cohesion. So basically, the main reason behind this cohesion is the reuse. So if we design a class or a method that's responsible for doing one well thing, then we can actually use it again in another context. So that's what our aim is. Basically, when we can actually reuse this class or method in another program if we want to. So we are basically calling it units which apply to classes, method, and module or packages. So this is for the first part of our presentation. I will create another recording for the second part that we are going to talk about. So this was just for the first part of our lecture, and I try to keep the lecture between 25 to 30 minutes, so it's not going to be that long for you. So you can watch my other video after you kind of, take some break. Talk to you in the other video. Bye-bye.